Hello and welcome to this Reigate College further mechanics video on momentum. So what we're going to do in this video is extend the ideas you came across in your Year 1 mechanics into 2 dimensions. So in 1 dimension and in 2 dimension, the impulse momentum principle applies. So impulse is change in momentum. So we think there of final momentum, take away initial momentum. In 2 particle collisions, conservation is still going to apply, so the total momentum before is the total momentum afterwards. Important to notice that these quantities here are vectors, and you must work with vectors when you're looking at momentum. So question 1, we've got a particle of 0.4 kilograms moving with that velocity, so that's its initial velocity. It receives an impulse of 8I minus 6J. Find the new velocity. You can either work in i's and j's, or you can work in column vectors. Column vectors slightly easier to see on the screen. So what we're going to say is the impulse, which is 8 minus 6, is going to be the change in momentum. So the momentum at the end, 0.4, and we're going to call the velocity at the end xy, minus 0.4 times the initial velocity, which is 2 minus 6. So we then look at the top line of this equation, and we've got 8 is 0.4x minus 0.4 times 2. That gives me 8.8 over 0.4 is x. So x is 22. Then looking at the lower line, we get minus 6 is 0.4y minus 0.4 times minus 6, so that's going to be plus 2.4, and that gives me minus 8.4 over 0.4 is equal to y, so y is equal to minus 21. Remember to state your answer. The new velocity is going to be 22I minus 21j. And I'm giving my answers in i's and j's because the original question was written in those terms. If you were asked to find the speed afterwards, you would need to find the speed of that velocity. Let's look at the next question here. We've got a body of mass 0.25 kilograms. And we've got its initial velocity. It receives an impulse, and we've got its final velocity. Find the magnitude of the velocity and the angle between q and the I direction. So we're going to say the impulse, which is q, is equal to final velocity, which is 0.25. Again, I'm going to go with column vectors. Final velocity 10 minus 7. Minus 0.25 or 6. You could write that as 0.25 and then a bigger bracket and subtract the 2 vectors for the velocities. You can write that, just be careful that you remember everything gets multiplied by the 0.25. So when you sort all of that out, you get that q is equal to 3 over 2i minus 13 over 4j. It asks for the magnitude of q, so the magnitude of q, usual method, is going to be 1.5 squared plus minus 3.25 squared, all square rooted. And that is equal to 3.58 Newton seconds. Then we need to find the angle between q and the I direction. So a little sketch will help here. Here's the I direction. This vector is 1.5i minus 13 over 4j. So that angle there, theta, is given by tan of theta is 3.25. That's what 13 over 4 is, divided by 1.5. And working that out on our calculators, that gives me theta is equal to 65.4 degrees. It'd be worth saying below the I direction. Moving on, we've now got a slightly more complicated situation going on here. We've got a ball with mass 0.2 moving with that velocity, hits a fixed vertical wall and rebounds with a velocity of -32 minus 9j. Find the impulse exerted on the ball by the wall. It's important to realise here that if I was to draw a plan view, we've got something like this going on. Here is the wall, and it's vertical in the sense that it comes up from the page. Then the particle is hitting it like this and then coming away if I was to draw a plan view of it. So just be careful that that word vertical means coming out of the page and your I's and J's are flat in the page. So we're trying to find the impulse again here, similar method. Q is going to be 0.2 and we'll do 32 minus 9 for the final velocity, take away the initial velocity, 44 minus 16. And that gives me 0.2 on a vector of -12 and 7. So that is -2.4. I'm going to go straight to I's and J's here, plus 1.2, 1.4 even, 1.4j. And it's asked for the impulse, it doesn't ask for the magnitude, so that is what we are going to give there. Final question. This uses the principles of conservation of momentum. So we've got a mass with a particle with a mass of 0.3, moving with that velocity. It collides with another particle. Find the velocity of the combined particle. So we use the principle of conservation of momentum, which is often referred to like that. So we've got the momentum before, that's going to be 0.3, and then the velocity before is 40 minus 8 for the first particle. The second particle, 0.5 with a velocity of 14 minus 6. The particles coalesce, that means they join together, so that's going to be 0.8 mass, and xy is what we're going to call the velocity afterwards. So we're going to solve this. When we add this through on the top line, we get 40 times 0.3 plus 0.5 times 14. So that gives me 19 on the top equals 0.8x. So x is equal to 23.75. And then the y line, we get minus 5.4 if we work out 0.3 multiplied by minus 8 plus 0.5 multiplied by minus 6. And that's going to be 0.8y. So y comes out to be minus 6.75. So the final velocity is going to be given by 23.75 I minus 6.75 j. So now you need to practice these techniques, working through some questions and working through the examination questions that are attached in the coursework.